We are officially streaming on YouTube. All right, cool. So if you're listening to this, then you're listening to the recording for workshop number 1 of the July 2022 boot camp. All right, so I think we got all the folks here that we're going to have. So welcome everybody to the first, I guess, official workshop of the July 2022 boot camp. We all met on Monday, or I guess some of us met on Monday to go over like, the more, broad stuff about this boot camp, but we didn't actually cover any material. So if you missed Monday, don't worry at all. And if you're watching this on the recording, that's totally fine. We're very flexible here in the boot camp. So I just shared my screen in Discord. So go ahead and click on my stream in Discord. And what we're going to do actually today is we're going to cover chapter 1, day 1, all the way up until chapter 2, day 2. So it seems like a lot of content, but it's actually not going to be too bad. So, ooh, love the game. Oh, that's a nice background you got there. And I love the flow hat. That's awesome. Nice. I see Numini in the chat here as well. What's up, Numini? Good to see you as well. All right. Love that background, love the game. Okay, so what we're going to do today is, this is going to be boring. I'm sorry. I personally am somebody that hates reading. In fact, when I was in school, reading was like my worst thing ever. It stinks. But we're going to get through it today, and then for the rest of the boot camp, we're not going to be reading anymore. But let's just take a second to read together, right? So chapter 1, if you've looked at it already, has like basically no coding involved. It's all like review. So stick with me here for like 10 minutes, 15 minutes. We're going to talk about the blockchain, what smart contracts are, and then I promise you we'll get into some more exciting coding stuff. But with that being said, let's dive right into it. So, the first day is really talking about learning blockchain concepts. Now, this is really just to kind of introduce you to some of the more complicated terminology you might hear, like DApp, testnet, mainnet, smart contracts, database, decentralized, like what all these things mean. That way, for the rest of the boot camp, you're not sitting there like confused about what we're talking about. So I guess like what is the blockchain, right? Well, you can really summarize it into 4, big terms: open, decentralized, public database. So what does open mean? Well, open means that anyone can interact with it. There's no restrictions. So when something's on the blockchain, it's open for anyone to interact with, in any form, right? It's not blocked. It's decentralized, so nobody, or theoretically nobody owns it. So there's no central authority dictating stuff, right? So when you think about Google, right? Like if we type something up in Google, Google has like a centralized database, right? So you can't add to Google's database, right? You can't go in there and remove information because Google owns it, right? They own their own little company and database, right? And all this stuff, right? But with the blockchain, it's decentralized, so nobody truly owns it. Now, of course, some people have said to me, well, Flow, the past couple of years has been centralized in that not everyone could deploy to it, but of course, with all blockchains and all technology, some things have to be centralized at first. But now with permissionless deployment, anyone can deploy their own contracts to mainnet. So that's sort of the decentralized theme. Now, database, this is pretty simple. This just means that you can store data on the blockchain. So all your NFTs, all your fungible tokens, all your other information, random information about stuff, that's all stored on the blockchain as well. And it's public, so anyone can view it. So this is a really important point. We're going to talk more about this in a bit. But from the very get-go, I want to mention that, with the blockchain, nothing is private. So no matter what we cover or what we talk about, always keep it in the back of your mind that it's impossible for anything to be private on the blockchain. So you never want to store private information on it because anyone can read it at any point in time. Even if we configure our data to be somewhat secretive, we'll talk about that later when we talk about access control. But everything is always public, right? So that's the more important point about the blockchain. If you want to read more about it, you can definitely read over this piece of text as well. So I guess with that being said, Ethereum is a blockchain, and Flow is also a blockchain. So of course we're going to be talking about the Flow blockchain because woohoo, we like Flow and screw Ethereum, you suck. Just kidding. But we like Flow better, right? So that brings us to smart contracts. So this bootcamp is learning about Cadence. Now, Cadence is the smart contract language for the Flow blockchain. So we all, woohoo, are going to be, learning how to code contracts. Okay. And so, why do we use smart contracts? Well, you know, one, because, they're efficient, they're fast, and they're accurate. So if you write a smart contract a certain way, it'll always do that action. So they're very accurate. And also, they're trustworthy and transparent. So, like we said, the blockchain is open for everyone to read. And so they're very transparent in that you can always go in, look at the code, look at the smart contracts, see what they're doing, and if you understand cadence, you can trust it, right? If you come to the conclusion that it's not malicious code. Now, this is another reason why we're in this bootcamp together, is because with permissionless deployment out, right, there's going to be a lot of people that are putting malicious code on the blockchain, malicious smart contracts. And so we are here to educate you on what Cadence is doing, so that if you ever don't trust a transaction or a contract, you can go in, read the code, and figure it out for yourself if you think it's safe or not. So part of this course is giving you the understanding to, verify your interactions with the blockchain. But, of course, it's also important to talk about the downsides, right? What are the downsides of smart contracts? Well, one, they're very hard to get right. So even though they're called smart contracts are actually incredibly stupid. And the reason I say that is because if you like smart contracts on their own have no idea what they're doing. You as the developer have to explicitly tell it what exactly it has to do at every stage of its interactions with people, right? So if you write the smart contract to be a bad thing, the smart contract will be bad. But if you write it in a good way and in a secure way, it'll be secure. So they're definitely not smart, but they are really useful in that if we become good cadence developers, we can write some really good code and our smart contracts will do the right thing. Now, two, of course, they can be malicious if the developer is mean. So if someone woke up one morning, wanted to be a really mean person and write a smart contract that, withdraws all your NFTs and withdraws all your tokens and steals them from you, they could do that. Now, of course, it's up to you as the user to not sign anything or send any transactions that would allow that to happen. Now, another downside of the blockchain is you can't undo something. So if accidentally mint some NFT or you accidentally send someone 100 flow token or whatever you may do, you can't undo it, right? There's no such thing as undo. The only sense of undo there is you would have to run another transaction to to do the opposite thing you just did, but there's no undo button. So you always have to be very careful with the things you're doing on the blockchain. Okay. And in addition to that, one thing I like to mention too is that, smart contracts, when you deploy them, that's permanent, right? They're permanently on the blockchain. Now, one cool thing about the Flow blockchain that's not, that's actually unlike blockchains like Ethereum, is that on Flow, you can actually upgrade your contracts. So this means that if you deploy a contract with a mistake in it, you can actually fix it. However, that's subjective. So there's some things that you can change and there's some things that you can't. We're going to talk about that later in the course, but just note that if you make a huge mistake, you can change it, but there's some things you can't change. So you do want to try and get it right from the get-go. All right. So that's what smart contracts are. Now, with transactions and scripts, we're not going to talk too much about this right now because we're going to spend pretty much the entire course on this. But transactions are ways that you modify the blockchain. So you change the data in the blockchain. Now, this could mean minting an NFT, transferring an NFT, casting a vote on the blockchain. I'm loving Rob's memes in the chat. That's great. It's official, true. If I say it, it's official. That's true. That's going to be a common theme throughout the course. But transactions change data, whereas scripts simply read data. So if when you run a script on the blockchain, you can't modify it at all. It doesn't change anything about the blockchain. You're simply reading from it, whereas with a transaction, you're writing to it or you're changing it. And so with transactions, they cost something called gas. Now, gas is what you as the user use to pay for changing the blockchain, for sending a transaction. Now, one of the benefits of the Flow blockchain is that gas is incredibly low. In fact, it's like fractions of a cent. So it's not really a concern on the Flow blockchain, but of course, on blockchains like Ethereum, it's a major concern, right? Where every transaction is like $100. So that's something just to keep in mind. All right. Now, one other piece of terminology I want to introduce to you is mainnet versus testnet. You probably hear these a lot, and if you don't know what they are, that's okay. We're going to explain it now. I'm going to zoom in a little bit, but testnet is basically like where everything is fake. So if you want to experiment with your contracts, you want to test them, you can do that on testnet. So it's basically like a separate the way you can think about it is it's like a separate blockchain that's all like fake. So you can deploy your contracts if there's a it's like a sandbox. So if you mess up, you can change it, you can do whatever you want. Basically, like you could send flow tokens. The flow tokens are fake; they have no actual value. They're good for developers to test their contracts before they actually release it to the public. Whereas on mainnet, everything's real. So all your goats, all your Flovatars, all your flow token, they're all on mainnet. Everything's real. Money's involved. Transactions cost real money, and if something bad happens, it's really bad, right? So that's what testnet versus mainnet means. All right, cool. And lastly, I know we're almost getting to the end of this boring reading section, but the last thing is talking about dApps. So you'll hear dApps. What that stands for is decentralized applications. So dApps. People pronounce it differently. I just say dApp. Some people say dApp, whatever you want. I think if you call it a dApp, you're stupid. Just kidding. But that basically they're just applications that involve the blockchain. All right, so that's pretty much it. Cool. I'm gonna mute that really quick. Okay, cool. So that is day one. Now, day two, we're going to go even faster just because, like I said, I hate reading. But day two, oh, also, before I go into day two, anyone have any questions or anything about the blockchain or flow or anything like that? And also, feel free at any point to ask a question in the chat or to unmute your mic. You can always interrupt me and ask a question. That's totally fine. I see JT is living the
I
dream
have a
is here. What's up,
question.
JT? Oh, sure. Yeah. Someone has a question?
Yeah. So my question is, like, I read somewhere that the Flow blockchain is like environmentally sustainable, or at least more sustainable than other blockchains. Like, is that true? And if it is true, how much value does it really add to the technology?
That's an awesome question. To be fully honest, that's a really good question. To be fully honest with you, I don't 100% know the answer, only because I deal mostly on the contract side and not like on the infrastructural side. Although I know that they actually have a web page. Anyone know what the link is called? It's like something.flow.org. We can actually check it out. Let's check out flow.com. And sustainability. So I'll send this link in the chat for you, Troy, if you want to check that out. But they have this whole page talking about like the sustainability of Flow. So I think this might interest you. I think part of the reason for this is because Flow is a proof of stake blockchain, um, which is like a whole separate protocol to like what's the other one? Proof of work. Where you have like a bunch of miners with like really complex computers like verifying transactions. Proof of stake is where you stake your flow token, and then those flow token are what are verifying transactions. So I think just based on that, the flow blockchain is automatically more sustainable. um, I hope that someone answers your question, and I'm sure if you have more questions about it, I think there might be some more better people to talk about it.
No, that definitely does answer my question.
Oh, awesome.
Um, yeah. I guess just a follow up question.
Yeah.
Is I was when I heard about that, I started like doing like basic research on like the different seem like a proof of stake and then proof of work blockchain. But does that really I guess what I'm saying is how how does that apply to like the price of like crypto coins or something like that? Like, does the infrastructure directly affect the price?
That's an awesome question. To be honest, I don't really know the answer to that. Again, because I mostly don't deal with the infrastructural side, but there are some really smart people that can answer that question. I think. Let me see. It did. Ricardo said something. Oh no, okay, that's separate. But yeah, to be honest, I don't entirely know that answer, but that's a great question, and I would take that question to the Flow Discord. I think that they would be able to answer that one there, that question. So definitely go to the Flow Discord and ask one of their people. They would give you a good answer.
All right, thank you, sir.
Yeah, of course. Love those questions. Oh yeah, Rob actually said look at the Flow white paper. Yeah, so the Flow white paper, I don't know where that is. It's somewhere. But they actually have a white paper for the Flow token, and I'm sure it would talk a little bit about that as well. Cool. All right. Um, I guess one thing I would say too about that is that like now that I'm thinking about it, this stuff interests me too, by the way. But one of the things I would say about that is that like one of the reasons that gas is lower on the Flow blockchain is because like the what gas is it's a payment that you use to help like to pay miners, in like the old world you would pay miners to verify transactions. So people would have computers like mining transactions and verifying them, and so the gas that you pay like on Ethereum goes to them for verifying them, whereas in like a proof of stake world, that's much less needed because there's no miners really, it's just people staking their flow. So that's sort of where the low gas cost comes in. But again, I'm not an expert there. Um, cool. All right. So yeah, so this is talking more about the Flow blockchain and Cadence. Again, there's a little bit of a history lesson. Just super quickly. Cadence basically evolved from way back in the day when Dapper, was doing CryptoKitties. This was actually a project on Ethereum, and one day, they found out that their project actually crashed the Ethereum network. That's like the historical moment. And then after that, they were like, you know what? Screw it. We're going to create our own chain. So they made the Flow blockchain. They made Cadence, and they made Cadence in a way that's, they thought would be much better for, holding assets. So one of the big themes of this course is going to be resource-oriented programming. And what that means is that the programming language is designed around creating and holding and really truly owning assets or resources. Um, and so you'll notice that like you might not understand this right now, but on the Ethereum blockchain, NFTs are actually stored inside the smart contract, whereas on Flow, NFTs are actually stored in your account, in your own account. So you truly own your own assets. And I think that this was largely a result of Dapper wanting to change the way that ownership really was, handled on the blockchain. So like Love the Game says here, it's, resource oriented versus object oriented, right? Yeah. So Corsair says, does each blockchain have its own language? It depends actually. So Flow blockchain uses Cadence. Most EVM networks like Ethereum, Polygon, they use like Solidity. But I think like Algorand uses its own language. So it really depends. But most EVM, which is the Ethereum virtual machine, most blockchains that run on the EVM use Solidity. So I would say Solidity is probably by far the most popular, but Cadence is specific to the Flow language. Cadence reminds me of Swift. That's because it actually was inspired by Swift. So Cadence actually takes after Swift and Rust, if you've ever used those two. All right. Cool. So some facts about Flow. It's much cheaper than Ethereum, yada, yada, yada. It's very new, so things are changing very quickly. In fact, permissionless deployment, just recently came out. There's little learning resources, and, NBA Top Shot is one example platform that's running on the Flow blockchain. So, um, and I'm going to skip over this, but, actually, I'll briefly mention it. One thing about Cadence that I like to talk about a lot as a teacher is that for beginners, Cadence is much easier to learn than Solidity, and this is coming from someone that has worked professionally as a Solidity developer and a Cadence developer. Cadence is much easier to learn. It also is structured in a way that makes much more sense. The way that Cadence works is they actually separate. So in Cadence, you have the smart contract, and then you have transactions and scripts that are written, that are separately written. So, you write a transaction, you send it, you write a script, you send it. Whereas in Solidity, there's no such thing as like the separation between the contract and the transaction layer. It's all intertwined, and so it's a lot more confusing. But well, again, we'll touch more about this in the future. So I think that the theme here is that Cadence is safe and secure in that Cadence makes it really hard for the developer to mess up. It's a lot easier to read. It's a lot more approachable. The developer experience is nicer because again, it makes it harder to mess up, and it's resource oriented. So we'll talk about that when we get to like chapter 3. All right, so we finally made it through the boring stuff. So if you hate reading as much as me, we're done. I promise we're never going to do as much reading as that again. But that is chapter 1 for you. So do you have any questions about chapter 1 so far? And maybe, if you want me to dive a little bit more in depth on some of the points about cadence, I'm also happy to do that as well, like what each of these things really means. But this quest actually asks you to dive into these 5 topics a little more deeply. Nobody says, will cadence be used elsewhere? Honestly, I don't know. I would assume not, but like maybe. I think we would just have to give it time. Can it? I don't see why not. I mean, in some world where, maybe Flow acts as a layer 1 and then some layer 2s come out on the Flow blockchain, that'd be pretty cool, right? I don't know if that would even happen though. That'd be pretty cool though. Solidity press TypeScript equals cadence. Yeah, I think in the type sense, like I agree with like the typing point because like cadence, the way it's written is like you have to be much more explicit about how you're coding it. But I think Solidity is just written. Solidity is so poorly architected, I think, because it's so easy to like put errors in there. I don't know. It's interesting, but I think that's along the right lines because TypeScript is, the typing mechanisms of cadence are so strong. No, you can't use cadence on Ethereum. No. All right. Only flow? Yep, exactly. Cool. So what we're gonna do now is we're gonna dive into some coding. Now, I always mention this, but because we're sort of at the beginning here, it's okay if you get lost. But I think if you look this over a few times, you'll definitely get it. Um, but yeah, let's do it. So here's our first smart contract, right? So what we're gonna do is we're gonna be working a lot on the flow playground. Now, if you've taken this bootcamp before, which I know that Numini has and a lot of other people in the chat, you know that it has basically become a meme in this bootcamp because it never works. But with that being said, we're gonna try our best to make it work. And if I complain about it, it's basically become a meme. So don't mind me. But anyway, we still love it, and we're going to use it for this boot camp. So be it. All right. So what you do is you go to play.onflow.org. I'm actually going to copy it, or let me just do this, and I'm going to paste it in the chat so you can all put up on your computer if you want to. But you don't have to. You can also just follow along. We're not like grading for participation or anything like that, so you're totally free to just follow along. Cool. So what is this? Well, welcome everyone. This is your first glance of Cadence code. So when you load up the playground, this is this is Cadence, right? And this is like a very basic contract, probably the most basic contract you can get. What I'm gonna do is remove some of these because I think the comments make it look more intimidating. And I'm also gonna reorganize it in a way that I like it because I don't like the way this is written. And I'm also going to get rid of this. All right. And I'm also going to change some of these things because I think it's a little more verbose than it needs to be. But here we are. Welcome to the most simple contract you can ever write in the existence of contracts. So what this is, I've said it before, but this is a smart contract. And so this smart contract does something. But the question is, what does it do? Anyone have any guesses on what this contract does? Just out of curiosity, like anyone, if you're coming from like a developer background, or even if you've never seen Cadence before, like, do you have any guesses for what this is doing? And if you've graduated the boot camp, you're not allowed to type. Pam says no idea. That's sneak. NGO says has variable greeting. It definitely does. Yep, exactly. Initializes it. Yep, exactly. World Destroyer. That's exactly the answer I was looking for. No, yeah. So, um, but yeah. So I think NGO pretty much nailed it on the head, right? Greg says declares the contract and then says hello. So yeah. So I think you're all getting the point. What this is doing is, let's go back a little bit. This makes a new contract. So it's as simple as that: public contract and then the name of our contract. So whenever you want to make a new contract, you type in pub, which just means public. We're going to talk about what this means later, but it's always pub. contract, which means we're making a new contract, and then the name of it. So we can name this Jacob is the best instructor in the universe, right? We could literally name it whatever we want to. Of course, this is a true statement, but to make it easier, we're going to go back to just simple hello world, all right? So there we have it. We have a contract hello world, but right now it doesn't do anything. It's very boring. Yeah, there's nothing to do. So we want to do something in it. We want to put a variable. Now, if you've never developed before, a variable is basically something that just stores information. We want to store something called a greeting. Now, this already is getting weird, right? What did I just type? Well, I typed in public. Now, again, we're not going to talk about what public is for a couple chapters, but just know that we put this public here, and this is called an access modifier. So we just put public there, and this let means, so I'm going to type this here, let means this is a constant. So if you've coded in other programming languages before, it's the same thing as like const. But let basically means that once we set this variable to a value, we can't change it. Whereas something called var means we can change it. Or I guess like someone could change it, right? So if we made this var, then it's possible for this thing to be changed at some point in time. Okay. But we're going to call this greeting. So that's the name of the variable. And then colon string, this is the type. So string is basically like a bunch of like, number, it's basically like a bunch of letters and numbers like this. That's a string. Whereas a number or something called, actually, I'll write this on a different line. So a string is like, a bunch of text like that. And an integer is like a number. So 100, right? And we're going to talk a little about this later, but like an array is like a list of items. So like, 1, 2, 3, 4, 5. So these are called types, all right? So this signifies that this greeting is like a string. It's a bunch of like, actual text, okay? So with that being said, we need to initialize this to something. And the reason for that, you can actually look at this error on the right-hand side. It says missing initializer for field greeting in type hello world. So the reason for this is because if we were to deploy this on the blockchain right now, it would, it would be nothing, right? This greeting it doesn't hold anything right now. So the contract isn't okay with this. It's saying that that's not an okay thing to do. So in order to actually set it to a value, I saw some people were making this mistake. They were trying to like say equals like, hello, or they were doing something like this, or some people were even trying to like put it in like things here. None of these things are things in Cadence. You can't do those things. The way you do them is you initialize them in something called an init function. So this init, you do init, you put these little colons here, or whatever, parentheses, and then these curly brackets, and then you can say self.greeting equals Jacob says hello. And that's it. Now our contract is happy. So what we've done is, again, we've made a greeting variable and we've initialized it, or basically set it equal to Jacob says hello, right? Pretty simple, right? Anyone have any questions about this yet?
So I'm pretty new to coding. Like, I mean, like a day, and
Yeah.
some change. Like, this is my first um having experience with it. So, is the equal sign like something that's common that you use? Like, is that like a rule in order to like connect two phrases together?
That's a really good question. So this equal sign basically says that this greeting variable, think of this greeting like a box. Like this box is going to hold some data. So it's saying that this box, the greeting box, is equal to Jacob says hello. So now this greeting contains this information, or it represents this information now because we're setting it equal to something.
Okay.
Yeah. And this is also like this is in general programming. This is usually how you like set things equal to something else. You just use the equal sign.
All right. Thank you.
Yeah, of course. All right. Yeah. So with that being said, let's go ahead and I'm going to delete these two just to make this more simple. But let's go ahead and deploy this. All right. So it now is deployed to contract one. Now here's a simple, a quick note about this. So what we're working on right now is the flow playground. So remember when let's go back to chapter one, day one for a second. I think it's here. Yeah, so remember we were talking about testnet versus mainnet. Mainnet's the real thing, testnet's the fake thing. Well, we're on something that's like over here. We're on something called the emulator. So the emulator is like the test, okay? It's like what you test on before you even go to testnet. So more, specifically like on the testnet, like everyone can still interact with it. So if I publish a contract on testnet, like you can still read from it. This is the emulator, which means that like this is literally just for me. So like I'm the only one that's going to be interacting with this. So you can't like make any mistakes here. It's totally fine. Um, so great question about self. So what does self mean? Self means the thing that's right above it. So if we think about like, the greeting variable is defined like on this level. So self just means it's referring to the greeting variable that's like above it. So right here. And if we put greeting here, it would actually would give you a problem. It would say, hey, you can't do that. So we can use self. Sweet. And also, I think that this is going to make more sense too when we start doing more complicated stuff. So, when we deployed it, right, we deployed it to account one. Now, what does this mean, right? What is like? So, do you see this thing on the left? You see, this is like an accounts list. So there's 5 accounts here. There's account 1, 2, 3, 4, and 5. Now, each of these accounts has something called an address. And an address is this thing right here, like the 0x01, 0x02. Those are addresses, okay? So that's sort of like how you identify the account. Now on mainnet, like let's go here for example. Like I'm just gonna put this down below. Like this is an example of an actual address. So let's zoom in on this. Oh wait, that's too much, I guess. Let's zoom in on this. This is an example of like an actual address, like 0x921EA44, right? So this is like a real address. These are fake, so like 1, 2, 3, 4, 5. But these are just meant to help you. These are just meant to help you understand, addresses in a more simple way. So anyway, all this rant is to say that we're currently deploying this contract to account one. All right, so this contract lives in this account. So what we're going to do now is I'm going to ask you all a question. We want to read this greeting from the blockchain. We want to read it. So should we write a transaction or a script to do that? Script, right? Good. So we want to write a script. So let's go down to the script tab and we're going to write a script. Now you'll notice it already makes some boilerplate stuff for us. So that's really great. Now let's go back to our chapter so we can start following along with our content again. Um, let's go down. So look, we just did everything that's here, right? So we're following this exactly. And now we're going to go ahead and write a script. So the way that a script is structured is you'll always see this thing like a public function main, right? And then, so it has this format. Now, what this means, this colon int, this means, I'll actually write this down. So the colon int, or let's write it like this. The colon int means um, uh, this function returns an int type. Now remember, an int type is like a number, like 10. It could be -10, -2 billion, positive whatever, right? So it's whatever like whole number is, it could be positive or negative, doesn't matter. So that's what this is saying right now. Okay. So what the heck just happened to my computer? Um, okay, that was bizarre. Okay, so let's go back to the script now. So what we want to do is we want to read our greeting. So what should we put here instead of int? What's the type of our greeting? String, right? We're returning a string, which is the greeting. So we're going to go ahead here and put string. All right. Now, of course, it's going to give us an error. Mismatch types, expected string. So it's expecting us to return. Return means, for those of you that haven't programmed before, return basically means we're sending whatever data comes after it back to the caller. And in our case, like we are the caller here. So it's saying, wait a minute, we are expecting a string type, but you're sending me an integer, aka 1. So of course this would fix itself if we put like hello here, right? So let's try and run the script, right? It says, oh look, we returned a type string and the value is hello. But what we want to do is we want to return the greeting. So The way that we're going to do that is, first of all, you have to import the contract. And what importing means is it means to bring in the contract code to our script so that our script knows what we're talking about. So the way that you import is you say import the contract name from the account it's deployed to. So what account is Hello World deployed to right now? What's the address of it? I'm gonna let a few people give it a shot. Yeah, it's one, right? So OXO1. So we import the contract name from OXO1. Awesome. So what we're gonna do is we're gonna return hello world dot greeting. All right. So what this means is we're gonna use the hello world contract. So hello world. So now we're in here dot greeting. So greeting is the thing inside hello world. So we're gonna use dot greeting. Okay. Dot greeting. Now I have a feeling because I know the playground so well at this point that it's not gonna work. Oh, it worked. Awesome. Okay, cool. So look what it returned, a type of string, and the value is Jacob says hello. Super cool, right? So we've already written our first contract, and we've already written a script to view that greeting inside the contract. Does anyone have any questions about this so far? And I'm going to look ahead just to make sure that okay, yeah, that's day one already. Let me just go here, make sure that this is all correct. Okay, cool. So anyone have any questions about this so far? Nobody says, I want to know how to send someone a DApp where they connect the wallet and give me permission to take all their. No, not allowed, Numini. We are not teaching you that. So, NGO says, could someone theoretically assign something to greeting? No, it's impossible. Now, remember, this goes back to what we talked about with smart contracts, in that if something is not written to happen inside a smart contract, we can't do it. So inside our smart contract, we didn't write a function to be able to change our greeting, so it's not possible. No one can change our greeting right now. Yep, so it's gonna forever stay Jacob says hello. All right. I'm gonna wait a little bit more to see if anyone has any questions about this because I know that this can be confusing at first. But then after, we're gonna talk about transactions. So how do we change this greeting? Cool. Seems like everyone is doing all right. All right, cool. So we're gonna go ahead and make a transaction to change the greeting. Okay, so now we're in chapter 2, day 2. So if you haven't programmed before, and by the way, for all the programmers that are listening to this, we're gonna get a lot more complicated in the next like week or so. So if you're very bored by this and you already get it, that's totally fine. But we're gonna speed it up in a week or so. So don't worry. But anyway, for the non-programmers here, so what this is a variable, right? So this contains data. Now, there's other things in programming called functions. Now, functions are things that allow you to perform an action. So we're going to make a function right now. I'm going to call it change greeting, and I'm going to explain what all this means in a second. But I just made a function called change greeting. So again, it's pub, but we're going to talk about what pub means in a different chapter, so not yet. Function, this means it's a function. So unlike greeting where we can do let or var, that means it's like a piece of data. This is a function, okay? And we're calling it change greeting. Now, with a function, you put these little parentheses here, and inside of here, you can put a list of arguments to pass into your function. So what we're going to do here is we're going to pass in a new greeting, and the type is a string. So that means that almost like think of this like a doorway, where this function saying you have to pass me a new greeting that's type string. All right, so like you have to basically give me a new greeting. And then inside these curly braces, this is where we can do our actions. So we can say self.greeting equals the new greeting. Okay. Now, based on what I told you about 10 minutes ago with this let keyword, Does anyone know why it's giving me this error? Cannot assign to constant member greeting. Why is it giving me this error right now? Anyone have any ideas? I meant,
I'm
yeah.
I'm not totally sure, but um, I remember you said earlier that things in smart contracts can't really be changed. So like when it's self greeting, like at the bottom is self dot greeting equals Jacob says hello, and then up there is self dot greeting equals new greeting. So like maybe that can't happen.
Oh, that's close actually, Troy. I'm glad you thought about that. So what I meant by that was that it's not that the data inside a smart contract can't change. It's that some of like the actual code in the smart contract can't change. So for example, if I deploy this contract, then it's going to be difficult for me to add new like logic and new data to this contract. That's what I meant by that. But if we make a function to change it, then we can certainly do that.
Okay.
So I see in here, Air of Grace says needs to be var. Exactly. Yep. So what let means is that this means that that greeting is a constant. So that means that our code is not allowed to change our greeting. But if we make it var, that means that it's basically signaling that hey, our code is allowed to change this now. All right, and now the error goes away. So Ngayo, I guess what are you mostly confused on? It also sounds like Yoda. Confusing this is. There's a nice GIF in the chat. So Ngao says, would a script be able to run this function? I'm gonna actually ask you, Ngao, what do you think? And no one else is allowed to answer this just yet. I want to see if Ngao can get it. Exactly. So a script could not call this. Well, I guess theoretically, like it could, but it wouldn't do anything. Because scripts can't change information on the blockchain. So you would only be able to call this with a transaction. Yep, exactly. So Bam says the contract itself, the rulebook cannot be changed. Oh yeah, nice Bam. I like that explanation. Yep, good stuff. All right, so what we can do now is we're going to deploy this contract. Now again, remember that this is all a fake simulation. So in this playground, it's really easy for us to change the code and change it. But if we run testnet or mainnet, we wouldn't really be able to do this easily. All right. So we deployed the wait, that I think it deployed. I think so. So let's go ahead into our script and let's try and read this greeting again. Let's make sure that it's still Jacob says hello, right? So we deployed the contract. The initial value is Jacob says hello. So let's make sure that it equals that, all right? Let's run this script. Jacob says hello. Boom. We did it. All right. Now I was going to ask you, how do we call this function? But I think I already answered it. We have to run a transaction because transactions can change data, right? Whereas, scripts cannot. So this is what a transaction looks like. Notice that it already imported hello world at the top, so this is already there. And a transaction looks a little different. We're going to dive much more in depth into what this prepare and execute stuff means in chapter 4. But all I can say is for now, don't worry about prepare. Worry about execute, okay? So execute is where we can put the actions we want to take in order to change our greeting. So inside of here, the way that we read the greeting was hello world.greeting. All right, hello world.greeting. So does anyone have any guesses? How are we going to call change greeting? How are we going to get to change greeting? What should I type right here? And courtside is a guess. Yeah, exactly. So just like with the greeting, in order to reference it, we said hello world.greeting. With a transaction, we're going to say hello world.change greeting. All right. Now, the difference is that this is a function. So functions take in some data. Remember that I said that this change greeting function is expecting us to pass in a new greeting string. So it wants us to basically send it a new greeting to change the greeting variable. So inside of our transaction, let's go ahead and inside these parentheses, we're going to send it a new greeting. And the new greeting is going to be courtside says hello. All right. And then after this, we're just going to log like transaction is successful. That way, if this transaction goes through, then after it changes the greeting, it's then going to log to the console that the transaction is successful. Let's go ahead and send this. Now, for now, it doesn't matter who we send this with. We're going to talk about this later, but let's do it with this account for now. Send. And it says transaction is successful, just like we logged right here. So what log is doing, by the way, is when you get to like testnet or mainnet, log doesn't actually do anything. But when you're in like an emulator like Playground, what log does is it basically just prints messages back to you so that we can confirm that that the code got to this point. So we know that the transaction is successful because it called this with no errors and got to here. So if we go back to our script now, let's call execute again. And boom, our greeting is now changed. Now it says courtside says hello. So awesome stuff, right? There it is. We basically wrote a script to read the greeting, and then we wrote a transaction to change the greeting. Now, one more step we can take is that instead of, because the annoying thing right now is that every single time that we want to run this transaction, we would have to retype in here like a new person. So let's say Bam wanted to say hello. We have to say Bam says hello. It's annoying to do it at this stage. What we can do instead is at the transaction up here, we can make some transaction arguments like a new greeting and pass in a string. All right. And then down here, we can change this to new greeting. And what's going to happen now is we can actually type it into this box. So if we type into this box, for example, Bam says, hello, right? This piece of text will go here, and then this will go down here and get passed in to the function. So if we send this, of course, the playground never works because it's annoying. So let me try and fix it really quickly. But the playground never ever works, and it makes it so hard to teach properly. And try again. Let's try and say Bam says goodbye actually, because Bam is mean, right? Maybe the playground will like that one. Let's send it, and it doesn't work. Ugh. Well, if we can't get this to work because the playground stinks, just know that basically this should work, and then in our script it would say Bam says goodbye, but the playground does not. Yeah, that's so true. Oh, that's so true, Red. It's not a workshop until the playground stops working. True. So true. Oh my god, that's so depressing, but it's so true. But let's try and redeploy this maybe and see if that works. All right, we redeployed it. Let's go back here. Let's say, bam, just work, please. Let's send that. Oh, all right. Looks like asking it worked. So the transaction is successful. Now inside of our script, let's see if it worked. There we go. Bam, just work, please. Nice. Thanks, Bam. Thank you, Bam. Round of applause in the chat. Thanks, Bam. Um, but yeah, yeah. Let's get a round of applause for Bam. Woohoo! All right. So does anyone have any questions about what we just did?
Yeah, Jacob, I got a question.
Sure. Yeah. Go ahead.
So I'm not really sure how to phrase this question, so I apologize about that.
No
But
worries.
the transaction GUI box thing is kind of confusing me, because I would assume would kind of want to write some transactions like this normally, but then how is the without that box, how is the information getting in there? Because like I mean, I make a bunch of transactions myself, and I don't remember ever filling out the information. So how does that information um, get moved in a transaction?
Yeah, that's a really good question. So I think so. Let's step back a little bit to why we don't want to do something like this. So let's go back to when we had this, for example, and let's just say like a hello. So like right now in the playground, like based on what I'm doing, it's quite similar, right? Like if I wanted to send a new transaction and I wanted to, send a new greeting to change it, I would just type in here like my new greeting, right? And similarly, if I still had the GUI here, I would still have to do that same amount of work and type in my new greeting, right? The difference is when you start thinking about actual applications. So think about like Float, for example, right? Float, like the where you mint NFTs and all that. So the thing with Float is that, or really any dApp or any application, is you want your transaction to be like static. You want it to be the same. So you don't ever want to go into your transaction and change this code. You want this code to remain the same. What you want to change is the parameters or the information you're passing into it. So what we can do is we can take this transaction, and this is never going to change, and put that into our application and just send it different stuff over and over again. And the way to send it new stuff is, well, on the playground, we have this little GUI here that allows us to send in new stuff. But in actual applications, the front end or whatever the user is interacting with could pass in, new information, and it would send it through some complicated means on some server. But I wish I could know how to explain this to you without actually diving into that. But I hope I'm making
Yeah.
sense in that, like, the goal is not to change the transaction code; it's to send it new stuff.
Yeah, that does make sense. I think my confusion is I don't think I have any experience connecting like front end to back end. So I think that's just where I get lost.
No, that's totally fair. I think like this when we wrap up this course, if you wanted to, if you were to dive into the dApp course, I think that would definitely answer this question. But I think for the purposes of Cadence, just know that when you want to send a transaction information, you always want to do that through transaction arguments. That way, this transaction itself can stay the same, right? Like we're never going to change this code; it's always going to stay the same. We're just going to type it into this box. Whereas if we had to type it into here every time, this is not good. So you don't want to do that.
Yeah, that makes sense. Thank you.
Yeah, of course. Yeah, command line arguments, tough cookie. Yeah, it's definitely like it's one of those things where it's like it seems like initially like it seems like it's the same thing typing it in here and the GUI, but when you start developing dApps, you'll understand why that this is or this is a lot better. If the contract had a function that just returns greeting and doesn't assign to it, could a script? Yeah, exactly, exactly. So if we, for example, if we wanted to make a function called public function read greeting. Obviously this isn't needed because we can just read this anyway. But if we wanted to, let's make a function that returns a string and it says return self.greeting. A script can absolutely call this because this is just reading data from the blockchain. In fact, let's actually try it. So if we deploy this contract, let's go back to a script. And instead of returning greeting, let's actually return hello world.read greeting. Let's see what it says. Oh, well, okay. Playground's being annoying, but it works. Uh, Man, my sometimes when I fall asleep at night, I have dreams that the playground works, and then I wake up and I start screaming. But let's try it again. Oh, it works. See, there we go. Boom, it worked. There we go. And Ngayo, just to explore your curiosity, let's not return anything in here. And inside of our script, let's do hello world dot change greeting. And let's pass in, let's make a new argument here called new greeting string. So right now it's Jacob says hello, right? So let's pass in Bam says goodbye because he's mean. Let's send it. Okay, well, again, Playground crashes, but point is that this will not actually work because it changes it. But once again, we've been struck by. Actually, the truth is, the Playground might actually be crashing here because we're trying to change it. But if it worked in the slightest, it would be more responsive. But yeah, and point is it won't work. Yeah, I don't know, but it doesn't work. I think that's all we had for transactions, is it not? Or this just, yeah, it is. So cool. And also if you want like a last boot camp, for those of you that were here, there was someone named Becca, and I was literally in tears, crying, laughing over this diagram, because someone said that my artwork was great, and then I showed them this picture. It was like this little smiley face. But anyway, if you want like a visual representation of transactions and scripts, you can always look here, and hopefully this will answer that question about the difference between these two. And this as well. You can tell my artwork is incredible, right? Cool. So I think that that's all I wanted to say for today. I miss Becca, me too. Although I think Becca will be coming back later in the boot camp because she's already like halfway through it. Vitalik Death Red Cadence, I could destroy Vitalik in a cadence battle. Easily. Easily. I could have Raven on my team and still win. Just kidding, Raven. Just kidding. Jacob, dare you to tweet that out? The problem is that if I tweeted that, I think Vitalik would get really triggered. And actually, you know what? We could okay, here's what we're gonna do. All right, new plan, everyone. We're gonna tweet that in hopes that Vitalik gets really triggered and tries to prove me wrong, and then learns cadence, and then the flow ecosystem boosts off that, right? Is that the goal here? Cadence battle? Yeah, we all know Vitalik. Yeah, we all know he dreams of cadence. We all know he has nightmares about me at night, right? Without looking, I think I could beat Vitalik. Yeah, without looking, I actually think that. Um, for those of you, for those of you that haven't come to any of them, we have cadence battles, 2v2 battles in Emerald City, where people battle to code a contract the fastest. And last time we did it, someone made me put a blindfold on, and I think didn't we still win? Yeah, we did. Oh, I didn't? I can't remember actually if I won or not. I think, oh, Bam won. Yeah, that's true. Oh, yeah, true. Bam won. Because Bam was also blindfolded, right? Bam, you sneak. The Padawan has become the master. Like some Obi-Wan Darth Vader thing going on here. Bam is Anakin Skywalker. I'm Obi-Wan. He's officially taken over. Bam cheated? How did Bam cheat? Darth Vader? Have you ever seen Star Wars, Bread? It's like my favorite show of all time. I have to downvote that one only because I love Star Wars. We have to get George Hotz writing cadence. Yeah, we do. Bam, that's not true. Bam, I would destroy you. Bam knows I would destroy him in a real battle. All right, everybody. Anyways, I don't want to keep you for too long. That was the point of today's workshop. So, yeah, I hope this makes sense. We covered very basic contracts, right? We covered what a transaction is, and we covered what a script is. So, yeah, so feel free to tackle the quests now. There's some pretty lengthy quests. I think you'll do a good job with them. And the next workshop is Friday. Let me send a link in the chat. The next workshop is Friday at 12 p.m. EST. And we're going to cover we're going to cover the rest of chapter 2. So chapter 2 day 3 and chapter 2 day 4. So hopefully I can see you then. Yeah, the workshops are always on the events tab. Oh, true. Oh my god, true. Thanks, Ricardo. Gosh. I should just have someone else start doing this. This was sick. Oh, thanks, love the game. I'm really happy you liked it. That makes me so happy. Don't leave yet. We have floats for you. Well, we technically don't right now because I always forget to make them, but I'm here. All right. I actually always make sure I copy the same format. Okay. Float it. Yes. We have some floats. Discord.gg/Emerald City. What's the description? I always make sure they're the same. Oh, it's number 1. Raven is so mad at me. Oh, Raven, you actually make me laugh so hard every time. Oh, you're right. Thank you, Greg, for that. Raven actually makes me laugh so hard every time it says that. Let me do July really quick. July. Soulbound. Limited quantity. How many people are here? Like 35, I'll say. Secret code is I destroy Vitalik. Is that how you spell it? Vitalik? Yeah. Okay. Destroy Vitalik. All right, let's create it. Yeah, Raven, I'm sorry. I think it's because Raven, sometimes Discord is glitchy and they don't like sometimes Discord's really glitchy. That's why, and like it doesn't like actually return the real list. I'm meaning to ask it about that. Let's test it. Yeah, so look, Raven, like look, I'll give you an example. So right now, for example, if I do /in Discord workshop, it says no one's here, but there's obviously people here. So I think it's honestly Discord's fault. I'm gonna email them about that. I don't know why they do that, but anyways. Here's the event, everybody. I'm sending it in chat. Remember, the code is destroy Vitalik. Program never wrong. No, the Raven, the reason is because so they use an API to get the current members, but the problem is that they don't update that API fast enough. So the solution is to fetch all the current members of the Discord, and if you do that, it'll work. But they don't have a fetch function for people in voice channels, so it doesn't work. It's like the weirdest thing. All right, I got my float. What did I get? I got second. Who beat me? Someone beat me. BZ? Probably. It's always BZ. I just sent my float in Discord. Bread sniped number 0. Nice, Bread. Nice. Let's see if the code is destroy Vitalik. Let's see if Bread's lying. So the first person here is this account. Let's see. Actually, let's try it. How do you get to that again? Well, let's just do /identify Bread. 30C7C. Yep, that's you. Yep, Bread got number 0. I guess it's not in like a voice channel one. That's weird, man. Um, number 8, Rip. How do I burn it? No, don't burn it. But you can actually. So this is, we just released the incinerator. So yesterday, someone burned my graduation float, and I actually cried for like 10 minutes. Yeah, it was actually so sad. I released a tweet I remember on Twitter, I sent the tweet that was like, "Hey everyone, Float Incinerator is live." Like I was like so excited. I was staring at my computer like, "Oh my god, this is so hype! I can't wait to see people burn some floats." The first float that comes down the screen is my graduation float. I was actually in tears. Hey, nice MPI, good stuff. Yeah, it's funny, right? No, I swear to God, I'm actually not kidding. I I um I promise you I'm not kidding because I took a picture. Well, I took a picture of myself in real life, like crying, and I was gonna like send a tweet like as a meme, but I couldn't get a screenshot of the graduation float. Why do people want to burn floats? So it's all lowercase, love the game. So destroy Vitalik in one word. Um, but courtside, I think the reason they want to do that is because they want to clean up their collections, and also because some people have been like airdropping floats to people and they don't want them, so we just made an easy way for them to get rid of them. Yeah. You can love the game. You can airdrop. It's just a lot harder. Um, it's just a lot harder, but because the person already has to have their collection set up. In fact, we're gonna go over that in this boot camp, why that's a thing. But you can airdrop. They just have to have the collection set up. Yes, the workshop was recorded, Vishal, so don't worry about that. It's totally recorded. Don't you worry. Yep, it's recorded at that link that Davon sent. Yeah, if you ever want to view my YouTube channel, /God, of course. Floats are dope and genius to have. Oh, thanks, Numini. Sending a big virtual hug to you. Zero cap. Yeah, true. All right, everyone. Knowing me, I could sit here for hours, so sorry about that. Anyways, yeah, that's all I have today. So see you on Friday. If you can't make it, it'll be recorded. Love you all. Hope this was helpful, and definitely read over the chapters if you need any reviews. So bye everyone. Peace out. Floats are flow version. Yes, MPI, but a lot better. Yes. Bye everyone. Have a great Wednesday. Have a great Thursday, Friday. See you Friday. Woohoo! W instructor, W student. Bye bye. Now I always forget to end the stream.